Section 2.6, Finding Equations of Lines. If we know the slope and y-intercept of a line, an equation of the line is y equals mx plus b, where m is the slope and b is the y-intercept. A line has slope 5/7 and y-intercept of 0, -11, so the equation is y equals 5/7 x minus 11. So now we want to find the equation of the line with slope 2/3 that contains the point -6, -5. So we know the slope is 2/3. Our equation is y equals m, where m is the slope, so it's 2/3 x plus b. We don't know what the y-intercept is. The only other thing we know is that it goes through the point -6, -5. So let's substitute x equals -6 and y equals -5 into our equation and see what happens. So we have -5 equals 3 goes into -6 -2 times, so -4 plus b. Let's add 4 to both sides. -1 equals b. So our equation then must be 2/3 x minus 1. That is our equation of the line. Let's find an equation of the line containing the point 2, 0 that is parallel to y minus 5x equals 1/4. Remember, parallel lines have the same slope, so we need to know what the slope of our given line is. Let's add 5x to both sides. So we have y equals 5x plus 1/4. So the slope of this line must be 5. So the parallel, that's what that double line symbol stands for, parallel slope is also 5. Parallel lines have the same slope. So our equation will be 5x, y equals 5x plus b. We don't know what b is, but we do know that it goes through the point 2, 0. So let's substitute x equals 2, y equals 0 into this equation and see if we can figure out what b is. 0 equals 10 plus b. Let's subtract 10 from both sides. -10 equals b. So our equation is y equals 5x minus 10. So that line is parallel to our given line. They have the same slope and they have different y-intercepts. Let's find an equation of the line that goes through these 2 points. We know that we need the slope and we need the y-intercept. If we're given 2 points, one thing we can calculate is the slope. Remember our formula? We need to designate one of these points the first point, one the second. I'm going to say this is the first one, this is the second one. And so we substitute our y values, 1 minus 5 over 10 minus 2. That will give us that the slope is -4 over 8, -1/2. So our equation will be y equals -1/2 x plus b. What is b? I don't know. We need to calculate it. So we need to choose one of those points. It does not matter which one. I'm going to choose this one because I want to. Substitute x equals 2, y equals 5 into the equation, and then we can solve 4b. So that gives us 5 equals negative 1 plus b. Let's add 1 to both sides, and we have 6 equals b. So now we know the slope, negative 1/2. We know the y-intercept. So that is our equation for our line that passes through the point 2, 5 and 10, 1. And you can verify that that's the correct equation by substituting both 2, 5 and 10, 1 into that equation, and it should work. Find an equation of the line containing the point negative 4, 7 perpendicular. Remember, perpendicular lines have slopes that are opposite reciprocals. So let's look at this line. Boy, I don't like the way it's written. I wish it were in slope-intercept form. Let's subtract 6 from both sides. Let's divide everything by a negative 3. And now we can see that the slope is negative 2/3. We want the perpendicular slope. This symbol stands, it's an upside down T, stands for perpendicular. So our perpendicular slope will be the opposite. It's negative, so it will be positive. Reciprocal, flip that fraction. And you get that the slope is a positive 3/2. So that is our slope. 3/2 x plus b. What is b? We don't know. Let's use our point. We haven't used that yet. Negative 4 is 7. Use our point. Substitute these values into the equation. 2 goes into negative 4, negative 2 times. So that gives us negative 6 plus b. Add 6 to both sides. So now we have our final equation of y equals positive 3/2 x plus 13. That's our equation to the line. So now let's look at this application problem. We have $100,000 worth of equipment. It's depreciated $12,000 annually. What does depreciated mean? It means it decreases in value. In this case, it decreases in value by the set amount of $12,000 annually. So formulate a linear equation for the value v of t of the equipment after t years. So our v of t will be $100,000, that's our starting point, minus, we're going to depreciate or decrease in value by $12,000 each and every year that we own the equipment. So use the model to determine the value after 5 years. V of 5, we take our $100,000 minus 12,000 times 5. Order of operations says we need to multiply first, so it's $100,000 minus 60,000. So the equipment will be worth $40,000 in 5 years. And that's all for section 2.6.